300 plus 1 IP. So we need to keep this in mind and do subnetting first. 300 and the given network is 10. See, this dot separation between every 8 bit is only for our convenience. We all know the size of IP address is not 8 bit. It's a 32 bit. So if this is 2 to the power of 0 and if this is 2 to the power of 7, this is supposed to be 2 to the power of 8. But for our convenience, we have put the dot and we have divided. Now, if you take the entire octet, you get only 255 maximum. But what I need is more than that. 300 plus 1. See, if this is 1, this is 2, and this is 4, and this is 128, and this is supposed to be 5, 256. And when I add up to this one is 7, when I add up to this is 15, if I add up to this, if it is 255, because the next number is 256, then if I add all this, it should be one number less than this place doubled value. If you double this, you will get 512. One less than this is 511. So sum of all these bit face value is 511. So here we are keeping for ourselves 8 plus 1 bit, 9 bit. The reason why I am not stopping here is, if you stop here, you will get only 255. But what we need is more than that. So I take additionally another 1 bit. If this is 128, then it is 256 here. You keep doubling, right? Because it's binary. 1, 2, 4, 8, 16. We keep doubling. So if this is 128, then this need to be 256. Now when we add all this, we take 511, we get 511. How do I know? You can add and see. Or 256, if you double, it will be 512. One less than that. I want to make it more neat. So this bit is what we are, just one bit is what we are giving for the host. So totally 9 bits are needed in order to get 300 IP address. Actually, you will get more than 300, up to 500 IP address. You will get 510 IP address, because out of 511, one will go for broadcast. So 300 plus 1, 301 IP address you are getting here. Additionally, how many you are getting? 200. It is okay, rather than wasting lakhs of IP address. Few IP address you are keeping it for future. See, in first place, you will not have that big department, 300 employees in one department. Very difficult to manage. The entire company itself, some companies have got only 300 employees. I always remember one company in Africa. They're very small, but the work that they do is very big. Very small actually. The entire population of the country is also less. Company is also less. But the work they do is big work. They're ISPs of ISP, meaning they're not ISP, they're ISPs to these lower ISPs. They are the providers for the provider. For example, if you take internet from Airtel, and some of us may be taking internet from Geo. So in India, these are the two companies we have currently. All others gone, vanished. So Airtel and Geo, they are not. They are just ISP. Who provides internet to them is the ISPs of ISP. If you see that company, that won't be too big because their customers are only few internet. So in India, there is only two customers for them. One is Airtel, another one is Jio. But for Airtel only, there is thousands, millions of customers, and Jio also. They only need more employees because they are retailers. Okay, anyway, even in that company, you won't need a 300 plus one IPS for one department. See, this type of question they ask in some universities outside India to check whether they know what if I need more than 255. If it is 255, it is within the octet, you will do it very well. But if it is 300, you need to take one more bit from here. All right, as usual, you will be incrementing by the value of this place. Value of this place is 2. So 1 0 dot 0 dot 0 dot 0 slash 23 10 dot 0 dot 1 dot 2 dot this bit only. From this bit onwards we give for network 0 slash 23 goes like that. So we are going to take this network, give it to this 10.0.0.0 slash 23, in which the first IP is 10.0.0.1 slash 23, and in this place is last IP address. So last IP address of this will be 10.0.1.255. That's the broadcast. Last will be 10.0.1.254. This is what you need to provide here. Okay. Did you understand how I get this? This is clear. Oh, you are correct in this part? Okay. Okay, then I only mistaken. Then your other answer also should be right. Oh yes, correct. Perfect. Right. Fine. So the next is you need to do subnetting based on this 11. This is right. This is right. This is right. Nice. This is also right. The reason why we took 2 is we are we are consuming here up to 1.255. So this is correct. This is correct. Next. Wow, this is also correct. Okay. The autocorrect slash 30. Only 2 bits needed, no? So for 2 appears. This is also correct. I did not see this one, so I was a little bit. Your answer is right. Let's move on to the next topic. Subnetting is over. So Cisco routers and switches have got an operating system, and it is called as iOS. Internet Operating System, iOS. It's Cisco's own IP address, operating system. Cisco's own operating system. But again, every operating system has got some predefined programs. Means they don't develop the program. For example, some people will create some application using Java with Oracle or something like that. Some will develop their application using Linux. Likewise, Cisco has also used Linux to develop this operating system called iOS. But you will not see any flavor of Linux when you configure iOS. So there's no need for someone to learn Linux to manage Cisco device. Not really needed. But behind the screen, it is Linux coding. We just use some friendly configuration commands to talk to the router. What do you need? For example, if I want to see the routing table of a router, I no need to type any Linux command. I'll type show IP route. See, router is an IP device, layer 3. So what routing table I want to see? The layer 3 routing table. So show IP route, easy, friendly commands. It won't be that easy to type a Linux command to get this info. In English, easily you can type. Linux is a different language. It's neither English nor Tamil, nor Telugu. Totally different. Right. So to speak to that language, they have some interpreter in the middle. You type show IP route, so someone is interpreting that someone is XML. So it will be given instructions in Linux language, though you type in plain English language show IP route. Behind the screen, someone is instructing, XML is instructing the routers to show the routing table in a nice output using Linux command. So you get the routing table. So this operating system, even though it is going to be a command line operating system, it won't be difficult for you to handle. Some fields and things that only if you have GUI, graphical user interface, like Windows operating system or Red Hat, Linux Red Hat or Linux SUSE, it is friendly. No. Not only the graphical user interface is friendly, even this is also friendly. This is much friendly for me than using a graphical user interface. Because in graphical user interface, the graphics is there. As a result, the process taken to show you the graph, take the input via the graphics, and then converting it into command, applying it in Linux format, that is going to take more processor. See, if I have a simple command line, which we have, not if I have, we have command line interface, CLI. That's how you call it, CLI, command line interface. If you have simple command line interface, the router is going to feel light. This one is very heavy. Which one? The graphical user interface is very heavy. So we are going to understand more about these routers and switches. First thing, router uses iOS, Internet Operating System. That's the name of the operating system given by Cisco. And the medium is CLI, not the GUI, not the graphical user interface. CLI, graphical user interface, is opposite of it. Sorry. Even though it is CLI, you should not get discouraged here because it is user friendly. If you know English, you will understand this commands and you will remember these commands. You will not need to memorize any of this command because all the commands are meaningful. I want to see the routing table, so I'm telling router, show me the IP routing table, because IP is the protocol based on which the routing protocol is built. So the routing table is built based on the IP route information, layer 3. Fine. Where does this operating system resides? Where is this operating system kept in a router? See, like computers, router also has got motherboard. Router also has got processor, operating system, which is iOS, which we just now saw. So the router also have got some hard disk, like computer. But right from the beginning, Greece, not too beginning, like at least 2000, from year 2000, I can say, approximately, Cisco stopped using the hard disk and instead they started using flash. Like today you say no SDE, SSD, software. Sorry, HDD is hard disk drive. Yeah, soft disk drive, SDD. Cisco used that small cheap kind of hard disk, very small plastic chip, like your pen drive, thumb drive, flash drive. Right in 2000 itself, Cisco started using it. The advantage is long durable. I mean, like I've never seen SDD getting spoiled like hard disk. Hard disk has got motors and spinning disks. So after a few days, it gets tired, and then motor becomes weak, and then the performance goes bad. See, the router is a device which keeps running non-stop for years. Non-stop. We don't even off it. So such devices cannot simply keep running a motor to store data. Hard disk will have motors. Hard disks are heavy. Hard disks are heavy in weight, and size is also big. So 3.5 inches. This one is only 2.5. And this one has got motor in here. See, this is an arm which will be going up and down, reading. You might have seen in the olden days gramophone, where you have a lot of discs. And then it's a magnetized disc where data is written. And this is the reader, the head, read-write head, through which we write to the disk and read from the disk. So in olden days, you might have seen this, and it is still in use in hard disk inside the disk. In the olden days, they used to have the recorder. Some used to call it recorder. A lot of old songs. Ennalu me tu the pai. That type of song. So the problem with that with that gramophone is anytime this motor will become weaker, anytime this discs, after running, it may lose its magnetic. There's actually a kind of magnetic coating there. It may go off, and you will lose your data, and it will stop working. But this is not like that. This is forever supplying you the data, unless there is no big electric shock given. If electric shocks given, maybe the circuits may burn. Otherwise, even this will also burn if you give shock. There's a different circuit inside. See, there's a green circuit. This is very thin and lightweight, and you see this shock resistance. This is more than this. So this can also allow you to store more data, depending on the capacity again. So
So the running configuration is stored in the flash memory.
we'll talk about that. No? I'm simply introducing you that Cisco started using flash cards very early days so that they can provide the customer a reliable, long running device. Also, for them to ship it, it will be cheaper. In transportation, if you have hard disk, it will get damaged. Sometimes it will damage the other components inside the router because the hard disk is heavy. So if someone throws that parcel when it is shipped from US to or from China to Sweden, maybe it may go via car or plane. They may throw it like another parcel. So to avoid all those damages, they introduced flashcards. Flashcards are more reliable, less in weight, more safe, durable. Now, where are we? So there is need for a storage unit, that is flash. Now this flash memory is what the first memory that the controller will read as soon as you on the router. The controller will send the signals to go and read flash memory, and this is where you have the internet operating system. Now after going and fetching the operating system, actually when I say fetching, it is not really going to use this operating system. From flash, it will take a duplicate copy of operating system and start booting. So the original operating system stays there undisturbed, means no alteration done to original operating system. It will remain there always, evergreen, without any alteration. That's not the way that your Windows machine works. Any changes that you make, the Windows gets altered. The Windows operating system gets altered according to your configuration. Whereas here, the operating system always stays there. It's more good. It stays without any alteration. Only a copy is the decompression of the compressed file means iOS will be in a compressed file. So it gets decompressed and it will start booting. On the way, it will go to actually, from there it is decompressing and getting booted to another memory here called non-volatile RAM, random access memory. That is where it is getting extracted. The operating system from flash is getting extracted to NVRAM, but on the way it will go to, I'm saying wrong. The operating system is getting extracted to another buffer called DRAM, dynamic RAM. Dynamic RAM, but on the way it will go to another kind of storage called NVRAM. And then it will load everything from the NVRAM. What will be there in NVRAM? Your configurations or configurations. that we made yesterday. You might have got the router yesterday, but as soon as you get inside the router, you put some configurations. Those configurations never impact the original operating system. Only those configurations goes and stays inside NVRAM. So today when you on the router, the operating system is decompressed. In that decompressed duplicate operating system, the configurations that is there in NVRAM is getting attached. And when you receive the operating system, you receive along with your yesterday's configuration. And whatever comes in NVRAM is what your screen is going to show you. Now, all that you see in the screen is from the DRAM. So the running configuration means what? All that you see is a running configuration. So running configuration runs from DRAM. What does this running configuration contain? It contains both the decompressed operating system, the duplicate operating system, a copy of operating system, along with our previous configurations. Now, that previous configuration seamlessly copied to your operating system when you on the router. Every time you on the router, every time you start the router. The operating system will be always same because the operating system never gets disturbed. So the decompressed operating system, yesterday, today, forever, it will be same. On the way, that operating system adds your yesterday's configuration. On the way, during the startup, as it is starting up, that is why this memory is called a startup memory. Startup memory. And it comes to the DRAM where all your running configurations on the screen will be shown from here. So this is called as running, that is startup memory. This is running configuration memory or DRAM, dynamic RAM. You can also say running memory, startup memory. The configurations that is inside NVRAM, they are used only during the startup time. So they are called a startup configuration. They're called a startup configuration. Now, those configurations after loading into DRAM, it is not going to be erased from NVRAM. So what I'm going to say is a copy of your yesterday's configuration is what getting attached to the operating system and shown in DRAM. So your yesterday's configuration is still there only even after copying into a DRAM. It is not erased. It is still there. So every time you start the router, this memory will be read on the way as the operating system gets loaded to the DRAM, dynamic RAM. That is why they named that memory as startup memory. Startup memory.
It has the boot file, something like that.
No, for that we have different location, ROM, read-only memory. That will have the mini boot in it. So ROM mode they will say. Why? Because it's coming from read-only memory. That is different one. That will be there in the hard disk, sorry, in the motherboard itself. It's like a mini boot mode. If you are using a computer, before Windows get loaded, a mini DOS operating system loads the BIOS. We have not installed any DOS anytime. It comes with a motherboard when it comes with a manufacturer. Likewise, this comes with the motherboard, the mini boot. Now, that mini operating system makes this controller to locate the flash, and flash has got the operating system that is extracted, decompressed, and as it is getting loaded to DRAM, it also loads the NVRAM configuration and provides you the operating system with the previous day configuration in the running screen via the DRAM, which is also called as running configuration. Right.
Just one more question.
Hmm.
So in the NVRAM, we have the configuration that are manually done or the default configurations.
No, there is no default configuration. Default configuration comes along with the operating system,
Okay.
which is a kind of default skeleton of the operating system. Say, for example, all the interface should be in a shutdown mode. We used to say no shutdown when we configure IP address. So that shutdown is default. And then Ceph, there is something called Ceph, Cisco Express Forwarding. That will be always on by default. So those things are not from NVRAM, those things are from the flash itself by default. That is how the operating system is developed. But only those things that you put after bringing the box from the router from the out of box, whatever you put is what going to stay in NVRAM. Otherwise, NVRAM is going to be empty. So
What is the difference between the configuration and running configuration?
running configuration may have something new that you configured today, but the startup configuration is the configuration that you left on the router when you switched off your router yesterday.
Okay.
When you switch off, whatever you saved is what getting stored into NVRAM. And today, when you on the router, it loads all those yesterday's configuration into DRAM. After it loads to DRAM, when you see those yesterday's configuration, you may do some alteration to that. So those alterations will not reflect in NVRAM until you save it. Running configuration has got both the saved configuration as well as unsaved one. Saved as well as unsaved. So if you fail to save before switching off the router, then your NVRAM will not have those things that you did today. It will have only up to yesterday's. So DRAM may have some extra information along with the default configuration, which is not there in NVRAM. Default that comes with the operating system. So every time you do new changes to the running configuration, which is only there in DRAM, the new changes that you make is only there in DRAM. It is neither in NVRAM nor in flash. So every time you do the changes, if you want the changes to be there for the next reboot, we have to push it to a location called startup memory, which is NVRAM. How do you do that? You have two options to do that. The classical way is you say copy. Instead of saying DRAM, you will say running configuration. You don't need to type fully, okay? Configuration. Just I used to type this much only. Copy run means running configuration to startup means NVRAM. So instead of saying copy DRAM to NVRAM, that will be more technical. This is user friendly. Copy running configuration to startup configuration. This is one way. See, if you're copying this configuration, then there is need for a name to be given. So when you say copy run start, it is going to ask you a question. Hey, do you want to save in this name? It will suggest a name. You want to save uh, as startup by hyphen config. You simply say yes or hit enter. Only then it will push the configuration in that name. All the configurations changes that you made will be impacting.
So we use a command called write memory. What does that do?
That's what I'm about to say. So I said two options to save. Thanks for helping me. In my sleepy mood, I forget. Okay, what was that second? What I should talk next? I appreciate. So I said there are two methods in saving it, and one method I explained, and then I was thinking what I should say next. You helped me. So there is another method to copy. Do the same job. You type WR, or you can also type write to memory. WR is enough. You don't need to type this write to memory and all. WR will do what do the same job. But the difference is when you say copy and start, it is suggesting a name. Should I use this name? If you don't like that name, you can say no and then give your own name, or you can no need to type no also. You can just type the name that you want. You can type the name that you want and hit enter. Whereas here, no suggestion, no naming convention. It puts its own name and save it. It randomly puts on name and it will save it. That's more than enough. Most of the people we use WR instead of typing this classical copy, run, start, and all. We put WR most of the time. We put WR. That reduces your time, configuration, etc. But behind the screen, the job done is same. Copying everything from DRAM and deleting everything from NVRAM and putting whatever is copied into NVRAM. It is not going to do alteration in NVRAM. Yesterday's configuration is there in NVRAM, but today you did lot of changes in DRAM. When you say copy and start, it is not going to see what is the difference between yesterday and today. Okay, this is the difference. Let me go and attach. No, not like that. It's going to wipe out everything in NVRAM and put whatever is there in DRAM to NVRAM. Because DRAM has already got yesterday's configuration plus today's configuration. So in that way, you can have the latest updated info in NVRAM. Right, next. That's the reason behind this name, startup config and running, because during the startup, it loads. After that, it will never be used, only when you save. Again, the NVRAM will get disturbed a little bit, and then that's all the role of NVRAM. So NVRAM and DRAM no need much space, no need much buffer. Just the commands that you type in, they are going to be saved. So if any disturbance caused, it will not be caused to iOS. iOS will be always fresh. Only these things are getting changed. The operating system extension is .dat. That's the file extension of Cisco iOS. .dat file. It's a file type. It's a compressed file type. Compressed. Which is in Flash. It won't take much space. Next is you can bypass NVRAM. You can bypass NVRAM. What does it mean? If you don't want your yesterday's configuration, but you do not want to delete it, let it be there, but I want to bypass it for a while. Meaning, I want only the default skeleton of the operating system. So I want the operating system to get decompressed into DRAM without loading NVRAM, without loading yesterday's config. I want the operating system to be the default one in the DRAM. It is possible. Bypassing NVRAM will bypass all your yesterday's previous day's configuration. Why do I need to bypass yesterday's configuration? Say for example, I forgot the password. I configured a lot of things for 6 months, but before 6 months I put some password. And I never turned off the router. So there was no need for me to recall the password and then put while logging in, because the router was not turned off for last 6 months. 6 months I'm running this router without turning it off. And I did a lot of changes. Those changes I do remember, but before 6 months I set some password which I never used because I never restarted and I forgot. And what happened, one new engineer accidentally turned off this router after 6 months. And now when he turns on, it is asking for the password. He comes to me. I say, I also don't know. I don't remember. So what is the option? I have to bypass NVRAM. Why? The password is in NVRAM. Only when it goes and loads the password, it will ask me the password. If I bypass, I'm not only bypassing the password, I'm bypassing all the previous 6 months configuration. It is okay. At least I'm allowed to go inside the router. I'll just bypass this old configurations and I'll load the operating system. I'm allowed inside. If you load NVRAM, it will allow you only if you provide the password. If you bypass NVRAM, no configurations including password, but you are inside the router. That's the good news. After going inside the router, after going inside the DRAM, you can say type show startup config. So when I type show startup, it will show you all the passwords that you typed earlier. Now you can start the router as usual, normally via NVRAM and use the password. So what I'm coming to say is, in order to rescue your device, if it is locked and you forgot the password, you need to bypass NVRAM, and it is possible. How and all I'll show you in the next class. Here I'm just putting some foundation for the next class. You can recover the password for which you will bypass NVRAM so that you will be allowed to go inside. If you do normal booting, always the NVRAM is loaded and the NVRAM will always ask you for the password. Means NVRAM will put the password to DRAM and DRAM will ask you the password. Without you providing password, not allowed to get inside. If you don't get inside, then how you will recover? So simple is we bypass NVRAM so that you will be allowed to see the startup configuration after you logged in. And when you see, you may see the passwords there. If it is encrypted, at least this will allow you to change the password. Yep. So this is what we are going to do in the next class. We are going to do an exercise of how to recover forgotten password of a router. We'll stop here.